So we just watched the chicken video, Charlie. Sorry, you'll have to check that out sometime.
What is Charlie?
Band thing
Oh yeah.
performance. A relation is someone from the same mother as you.
The same.
No. In math, what is a relation? It's hard to describe.
My nail polish.
Anything you can graph is a relation. An equation with two variables gives you a relation. It's like when one changes, the other one changes. I didn't like the answer on this, on the answer key.
You can't just say it's the same terms.
A set of ordered pairs. That's like, okay, I guess, yeah, that's a set, a whole collection of ordered pairs. Because if you put all the ordered pairs on the graph, you would have the thing. Okay. The domain is the set of, what is domain?
Input value.
Input values or x values. Input and x, same thing. The range is the set of y values. In order to be a function, there can be no repeating x values. And to check if a graph is a function, use the vertical line test. I'll explain how to do that in a second. So basically, you're going to look at these and say, find the domain and the range and say if it's a function. I'll show you how to do number 3, because that's weird. So these arrows just mean when x is 4, y can either be 2 or 5. When x is 6, y is -1, and when x is 7, y is 3. So that's just like on a graph, all that would look like would be 1, 2, 3, 4. When x is 4, y is either 2 or 5. Then when x is 6, y is -1, and when x is 7, y is 3. So it's just a collection of those points. So what is the domain of that? It's just the x values. 4, 6, 7. And the way you write it, in this case, when they're just individual numbers, you put curly brackets. You know what curly brackets are?
Yeah, it's like
It's just a set.
little point.
It's just a set of numbers. So it's just 4, 6, and 7. Then the range would be just those numbers. Usually you write them in order from low to high. So it would be -1, 2, 3, and 5. On a graph, the domain and range is a little, or on something where it's not just individual dots, the domain and range is a little different. So like on something like this, the domain is the set of all of the x values on this graph. Which x values does this graph hit?
Decimals.
It hits decimals. It hits 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Does it go on forever to the right? Yeah, there's an arrow. It goes on forever to the left.
Yeah.
So what's it hit? Everything. And how do we say everything in math? Kind of. All real numbers. The range is the set of y values that it hits. So I always like to work from low to high. What's the lowest y value this graph hits? -1. So I'm going to go -1 and it actually hits -1, so it's going to be less than or equal to, and put a y. That means y is greater than or equal to -1. What's the highest y value that it hits? 2. So then you'll just put less than or equal to 2. So y is everything between -1 and 2.
Okay.
That kind of makes sense. We might have to do more practice with that, but that's your quick version that we only have 6 minutes left in class. Is this a function?
Yeah.
It is not.
No, because they're repeating x values.
Yes. Well, it doesn't matter if an x value, that's actually not completely true. X values can repeat as long as they go to the same y value. But you can't have one x go to two different y's like that. So this one's a no. This vertical line test thing is for a graph. If you draw a vertical line anywhere, it should only hit the graph once. If it hits it twice, it's not a function. If it only hits it once, then it's yes. So no matter where I draw a vertical line along there, I will only hit the graph once. Therefore, it's a function. And that also means that, like, no matter which x value I pick, when I draw a vertical line, if it only hits it once, there's only one y value. But if I have a graph, like a circle, if I draw a vertical line, it hits it twice. That means for this x value, say that's 3, there's two different y values. That is not a function. It's just a relation. That will probably be on your SPAC. There'll be a question like, is this a function? So you'll just got to remember that. Okay. Ooh, you're going to have homework tonight. You got to go hard though. You know what this stuff means? Have you seen this? F of x equals negative x
Yeah.
minus 7. Find f of negative 5. What is that asking?
Sub negative 5 is for x.
Yep. It's just saying, hey, x is negative 5. Plug in negative 5 for x. Clean it up. And if there's multiple x's, yes, you plug it in for both. So like 8g of negative 2 equals, you just plug in negative 2 for the x's. And then negative 2 squared is 4, negative 2 times negative 2 is plus 4, plus 11, 8, 19. G of negative 2 equals 19. You know what that means on the graph of that?
Negative.
When x is negative 2, y is 19. It's just a point on the graph.
How do you do 11, 12, 13?
11, 12. 11 and 12, just find the range of the function if the domain is this. So if those are the x values, what y values would you get? So basically you just plug all three of those in, and that will give you your range. You'll get 3 different y values. Same thing here. Plug all 3 of those in for x, you'll get 3 different y values for your range.
So we have each individual one.
Yep. This 14 is backwards. It gives you a function and says f of x equals negative 13, find x. What do you do there? Just
You just
plug-
say negative 13 equals 5.
Negative 13 equals 5 over 2x plus 7. Let's find x, solve for x.
What about 13?
Huh?
13, that's my biggest question.
I'll let you think about that. Gotta keep some.
So what's that number?
What's f of 3? I'm not done. F of 3. We gotta. That just means when x is 3, what is y?
Oh,
Okay. Zeros. The zeros of a function are where it passes through the. Come on, you should know this. We've talked about this. Haven't we? Huh? X-intercept. So it's where it passes through the x-axis. Zeros mean x-intercepts. If you've got the graph, just look at it and find the x-intercepts. If you don't have the graph and you have the equation, set the equation equal to 0 and solve for x. So you put 0 in for y. We've done that, right? Where you put 0 for y to get the x-intercepts. So that's all you're going to do on these. Find all the x-intercepts. Put in 0 for y, solve for x.
what's our homework?
1 through 23. Whew. Luck. Sorry to lay it on you like that, but.
Where's it going?